Our next presentation is Sam Dalen from ANCAP, who'll be talking about some of the testing that they do on vehicles.
Thanks, Rodney, and good afternoon, everyone. Just before I start, I wanted to reiterate what Evan Walker said earlier today. Coming from a vehicle safety perspective, I think today's been great for me to hear different perspectives about road safety and the things that are happening to us on our road. Sorry. Cheers. Thank you. Today has been great for me to be able to hear everyone's perspectives, so thank you very much. I'm Sam Dalen, engineer for ANCAP Safety. So there was a question earlier today, what is ANCAP? ANCAP, or the Australasian New Car Assessment Program, is an independent, non-regulatory consumer information organisation. So we crash test and performance test new cars that enter into the Australian and New Zealand markets. And our purpose is two-pronged. So initially is to provide information and influence consumer decisions on which vehicles they purchase, but also to encourage vehicle manufacturers to improve the safety of their vehicles that are going onto the roads. So over the past 30 years, our organisation is, I think, 31 years old now. We've had great success in being able to influence the vehicle safety of vehicles on our road. Our work is complementary to regulation. So our testing and assessment program is above and beyond what the Australian design rules mandate as the base safety level of a vehicle. So ANCAP's testing is generally a far higher standard, what the minimum requirements are. In terms of what we do, so in a test program of a new vehicle, we do 7 destructive crash tests and over 400 individual active safety tests. So active safety is the advanced driver assistance features, so autonomous emergency braking and lane support or lane guidance systems. Each of those tests is analysed by the team of engineers and goes into filling out the metrics in these 4 pillars. The key thing to note in this assessment is that we have a strategy of assessment that the minimum score for each one of the pillars is the rating or the grading that the vehicle receives. So the expectation on vehicle manufacturers is to perform well across the variety of different criteria. So adult occupant protection, child occupant protection, vulnerable road users, which includes pedestrian protection and collision avoidance with pedestrians, as well as safety assist, so avoiding collisions with cars and lane support guidance. To frame, I think, regional and remote road safety, I wanted to put up some statistics and why this is of particular interest for ANCAP safety. So in 2022, of the 1,185 road deaths, 2/3 of those were unfortunately in rural and remote road areas. And over the last decade, this has been a statistic that's remained relatively unchanged. Recently, the National Road Safety Strategy framework has outlined a few of the potential contributing factors in this. So put them up there. But I think for today, increased roadside hazards is the area of interest. So animals and environmental factors. Now, these aren't my statistics. These is data from insurance agencies, so the AAMI group and NRMA have conducted studies on their insurance claims over a period of a few years, and what they've managed to determine was that over a year, kangaroos represent a disproportionate amount of reported claims and vehicle strike data. So over 80% of reported claims and vehicle strike is for kangaroos. And I think Rodney mentioned earlier that the IAG group have estimated that over 10 million animals die on Australian roads every year. So that was a bit of a background. Now I'll go into a bit more detail. I know Evan mentioned that ANCAP do a lot of testing at the Future Mobility Testing and Research Centre. What I wanted to do today was kind of go into a bit of the technical background of this and why we're being able to see flow-on effect and actual safety benefits in the testing that ANCAP does. So at the moment, our testing is designed to encourage safety performance in a range of everyday scenarios. With our current testing is to avoid, recognise and react to car, motorcyclist, bicyclist, adult and child pedestrians. But to ensure that the testing and scenarios that we do in our lab environment have that flow-on benefit into everyday situations, we need our test targets to be realistic to the vehicle sensors. Each of the vehicle sensors, vehicle targets, have gone through a rigorous validation process, and in certain criteria, which I'll go into a little bit later, they are representative to the vehicle and the software algorithm that's within. So I thought now would be a good time to have a video and show you the testing of these cars. So interestingly, this vehicle was tested to our previous level of protocols. Since that time, we've introduced motorcyclists and a lot more complex intersection scenarios. I think, as mentioned before, this vehicle was tested at the Future Mobility Testing and Research Centre in Kewdale. Now, each of those tests, there was no driver input. This was all done through vehicle systems. The avoidance was completely autonomous. So into the detail about the test targets. And while I do this, I think I'd like to encourage you to think about how this would apply to animals and what we could do in terms of test targets and developing something for specific animals. So the vehicle-to-vehicle testing with AEB is conducted using a soft target vehicle known as the GVT. So this is a vinyl and foam. This is made with vinyl and foam panels held together with Velcro, mounted on a GPS-controlled platform and driven around. I think the vehicle can reach about 120 kilometres an hour, I believe. So how this is representative of a current vehicle, visually you can see that the GBT has been printed in a way that you've got your headlights, you've got your interior silhouette, but you also have light and dark spots, so where the radiator is kind of located. Individually, so the vehicle is also designed, and you can't really see this by looking at it, but it has been matched to base reference measurements for infrared so using a specific wavelength band to make sure that the light component, the white panels and the plastic or glass panels match the sort of reflectivity that you'd see in an actual car. But the radar property and radar cross-section is matched as well. So having been a vinyl outer skin, they've sewn a metallic film in between the vinyl layers so that what the radar cross-section is and what the vehicle sees is representative of the vehicle that it's trying to mimic. So going into our two-wheeler targets, so we test for an adult bicyclist and for a powered two-wheeler. So both of these test targets have a 50th percentile average adult rider, non-gender specific. The powered two-wheeler, so the motorcyclist, is mounted on a GPS-controlled platform. The cyclist can be mounted on the same platform or on a belt-driven system on the odd event that there are some equipment failures. In a similar way, these were both designed to visually match what a test target, what a motorcyclist or a cyclist would look like to a vehicle camera, and the infrared wavelengths as well. The radar was made to replicate a range of, again, base measurements of bicyclists or motorcycles, and there are design tolerances applied with that. Interestingly, with the wheels of the bicyclist, they're made to rotate in accordance to the speed that the bicycle's travelling, but there is an internal component within the motorcyclist that has the Doppler effect. We mentioned that a little bit earlier, but it is important to a vehicle sensor to kind of sense that the motorcycle is travelling at the same speed that the vehicle's registering it to. And finally, looking at the adult and child pedestrian. So I left this one as the last of the slides for the target realism, because I think this is the one that's most relevant to animals, and the sort of design and development of these targets could be matched to any kind of animal target that's in development. So visually, the physical proportions and the posture are based on on a measurement database of globally average global people. There was also video analysis done on people walking to determine the average gait size, so average step size, the timing, and knee and ankle speed. So those legs for both the adult and child move during the testing, as you would have seen in the video. So infrared also through the same bandwidth that the other test targets were developed with. Although in the development of the targets, they noticed there was a fluctuation in the wavelengths that the vehicle would sense. So there was a tolerance allowed within that. So radar as well. Both of the targets are designed to match what an average person would appear to a vehicle. The arms don't move. Interestingly, in these targets, the arms don't move. In the analysis of vehicle movement, people movement, they noticed that the arms didn't have the same level of influence on radar cross-section as articulating legs. So in thinking about kangaroos and how the greater mass or the leg size of a kangaroo is greater than the arms, that'll have a similar sort of effect in radar cross-section measurements. So addressing animals and vehicle sensors. So there are some challenges and gaps in current vehicle technology. We see traditionally a radar and camera fusion systems and occasionally camera-only systems. So with respect to Australian marsupials, They come in all shapes and sizes, which means that there's a greater radar cross-section, and one sort of bandwidth or expectation with vehicle sensor would be very hard to apply to each of these animals. They're also typically nocturnal, so for camera recognition, that makes it incredibly hard. The camera's only able to see what the headlights can see and what the driver can see, so the reaction time of a vehicle system is quite delayed. They're also, the colouring of the animals tend to blend into the environment, also making it very hard to recognise from a camera. Their movement is fast, agile and unpredictable, so from a software perspective, it makes it hard for a vehicle, even though they might be detected, to react accordingly. But in saying that, there is definitely opportunity. I think, not to talk down about the kangaroo target that we've been referring to before, but there is absolutely every chance that you could apply the development of the vehicle targets that we use now into measuring the same sort of criteria for the animals to develop a target to be used in testing, research and development of vehicle manufacturers. So, in summary, I think what would be really good for, I guess, local manufacturer development would be to have something that represents our local animals. At the moment, we don't really have a test target that local vehicle manufacturers can tune their systems to. So I think if there is any opportunity in what I've presented today is to be able to do a research program and have those reference measurements and reference data available for vehicle manufacturers to tune their systems. Thank you.
Great. Thanks, Sam. There's a few questions.
Great.
The one that's got the most ticks is, do you think one-day cars could get a wildlife safety rating?
Not out of the ordinary, no.
Not.
I think for an ANCAP rating, the active safety testing takes about 5 weeks at the moment, so all of those 400 plus tests. Certainly not out of the scope of testing. I'd love to see it, but we'd have to reduce the test time of the existing scenarios.
Because I'm thinking about, the majority of collisions were with kangaroos. So we actually don't need, the priority would be to focus on kangaroos as the test case rather than others. Yep. And I guess the challenge, I think someone alluded earlier to, was it Volvo that had given up on testing for kangaroos because it's just too erratic? Yep, correct. And I guess the target just isn't there as well. So, what do you mean by target? Test dummy. Okay, sorry. When I think about that now. Evan had a kangaroo test dummy. That kangaroo test dummy doesn't have the same reference information behind it. Effectively, it's a canvas bag filled with cloth. So it wouldn't be recognised by a current vehicle sensor as a kangaroo. Okay. And I guess finally, would ANCAP be interested in developing test objects that mimic thermal signature of different animals, or I guess not necessarily thermal, but just testing? Would you be open to collaborations to do that? Oh, absolutely. Yeah. So I think outside of this presentation, I'd encourage you to reach out to ANCAP or the Future Mobility Testing and Research Centre through Transport New South Wales. I think those guys definitely have the expertise and the equipment to be able to do this sort of research. Yep. Fantastic. All right. I think we do need to move on. So Thank you, Sam. No worries. Thank you. Thank you, everyone.